We're not just building a sci-fi elevator, we're bringing it to life, rigged, animated, and fully playable. In this video, we're taking our sci-fi elevator to the next level, rigged, animated, and fully functional in Unreal Engine. Hi everyone, welcome to episode 2 of the Sci-Fi Elevator Creation Series. In this episode, we're going to rig and animate our elevator, then import it into Unreal Engine and use. First, we create a single bone for the root, which controls the overall movement. Next, in edit mode, we create 2 more bones. Their purpose is to open and close the seat. Next, we create a parent-child relationship between them. Next, we select all the meshes and join them together. After that, by pressing Ctrl+P, we assign them to the armature. Now, in edit mode, we assign the main structure to the base bone, the seat connector rod to the rotator bone, and the seat itself to the drawer bone. As you can see, in pose mode, the bones are working perfectly. Now it's time to create the animation. In this part, we'll only animate the seat, since the elevator itself only moves along the Z-axis and doesn't require special animation. We create a new window and set it to dope sheet mode. Then switch it to Action Editor. The animation will work like this. When the seat closes, it slightly moves outward first, then continues to close so it fits perfectly into place. It's not a complicated process. We just need to create keyframes for each bone and adjust their positions accordingly. Now we're ready to export. Select both the armature and the mesh. Then choose Export Selected Objects from menu. After that, adjust the mesh and armature settings as shown in the video, and keep the rest of the settings the same. Now I open Unreal Engine and create a new folder. At this point, we can import the elevator, which includes the skeletal mesh. Import the textures as well and assign them to the materials. How we create a blueprint and add our mesh to it. We also add a box collision so that whenever the character enters it, they can interact with and affect the elevator. Now we go to the event graph and delete all the existing nodes. Then, by selecting our box, we add the onComponent begin overlap and end overlap events. Next, we add the enable input and disable input nodes, and then add the get player controller node as well. This way, when the character enters the box, they'll be able to trigger a reaction. Now I want to test the first scenario, where the elevator simply moves up and down continuously without stopping at any floors. We add a key, such as the 1 key, and then connect it to a set relative location node for our elevator. Now we split the location, connect it to the z-axis, and then proceed to test it. The issue we have is that, since the stairs don't have any collision, we can't walk up them. So, we open the mesh, then create a simple collision for it. Now, it's time to place the blueprint in the scene instead of the mesh. and then add the stairs and columns to our blueprint as well. Now, to get our desired scale, we add a simple box, and then add another elevator. As you can see, just like the settings we had in the first part, it's correctly set to 400 centimeters. Now, when we press play, the elevator moves 400 centimeters upward. Now, for example, we can create additional buttons, and by pressing them, the elevator can move to different floors. The next issue is that we still can't stand on it, so we need to add a collision to the floor in the blueprint. In the settings, search for collision. Set its mode to block all, and make sure the Can Character Step on It option is checked. Now, to make the movement smoother, we need to add a timeline to our work. Next, open it, click on the track area, and add a float track. Set the length to 5 seconds, then create 2 key points. The first at 0, 0, and the second at 5, 1200. Next, set the interpolation mode to auto to achieve smoother movement. Next, we connect the timeline's alpha output to the z-axis. And as a result, we'll have a smooth and natural movement. You can do the same thing for different floors as well. The problem we have now is that when we press 1, 2, or 3, the animation plays from the beginning each time, and that's really not ideal. Now we want to implement the next scenario. First, we delete the other timelines and keep only one of them. Set the timeline with keyframes at 0, 0, and 1, 1. we add the lerp node. Alright guys, let's dive into one of the most commonly used nodes in Unreal Engine, the lerp, or linear interpolation. The lerp node is typically used to create smooth transitions between two values. For example, moving an elevator from the lower floor to the upper floor, or smoothly changing a light's color from green to red. Now we connect the timeline's alpha to the lerp node's alpha input. As you can see, we have point A and point B. We set point B to 400 and connect it to our z-axis. As you can see, we now have a smooth movement up to 400. Now, instead of setting the value directly in the blueprint, we can add a scene component and set its value to 1200. We can bring it into the event graph, use getRelativeLocation to extract its height, and then connect it to the lerp node. Now we can duplicate our nodes, change the key input, assign it to 0, and then swap the lerp inputs accordingly. Also, change the play type to play from start. As you can see, we now have a smooth bottom-to-top movement working perfectly. The next scenario we're going to work on is making our elevator move floor by floor. So, in the blueprint, we create 3 scene components and assign a different height to each one. Now we need to create a variable for the floors, change its type to scene component, and then set it to a soft class reference. As you saw, we set it to set mode, then added a make array node, and, for example, created 3 pins for it. Now, we assign each of the scene components, the ones we set different heights for, to the make array node. We then add a begin plane node to it. And with that, we're done with this part. Now we add get floors, then make a copy of it and connect it to the target relative. For example, we set it to 1. So now, the elevator executes pin number 1 and moves up 1 floor. We make a copy of the nodes and assign them to the 0 key as well. Once again, the elevator moves straight down. So, we go to the graph, swap the input for 0, and connect it to point B. Then, connect the Z value of the 1 key to point A. This way, the movement will work correctly. Now we need to create two variables, next floor and current floor. We change their types to integer. And then use next floor instead of the direct values. We do the same for the one button, but in that case, we use the current floor variable instead. Now, to make the elevator move one floor at a time, after the one button, we bring in set current floor and connect next floor to its input. Then, we add get next floor and connect it to a++ increment node, so the floors increase one by one. Now we have the one-by-one movement working. For the 0 button, we copy the same nodes, but instead of ++, we use. We also copy the other nodes we use for the one button and try to organize the graph to keep it clean and structured. Now, when we play the animation and press the up button, which replaced the 1 key, the elevator goes back to floor 0 after reaching the top floor. But we don't want that to happen. Instead, we want a message to appear, so we'll add a condition. First, place a branch right after set current floor. Then, get floors, add a length node to find how many floor pins there are. Subtract 1 from it, because we have 3 items and arrays start at 0. This gives us the last valid index. Now set the condition so that after pin 1, it can't move up any further. And instead, it shows an error message. We do the same for the down button, but this time, the condition is that if it's equal to 0, the elevator won't move down any further. Finally, just like in the previous tutorial, we export the seat animation from Game Asset Lab, import it into Unreal Engine, and assign it to the elevator's skeletal mesh. We then create a key, such as E, and connect it to Play Animation, assigning our animation to it. We also add a collision for it and set up Begin Overlap and End Overlap events. Finally, we import the second animation as well and assign it in the same way. Thanks a lot for watching. If you found this helpful, don't forget to drop a like, leave a comment, and of course, subscribe for more epic game asset breakdowns. Your support keeps this series going.